So first of all, you have to understand what is all pair shortest path. What is all pair shortest path? Okay. So we consider the problem of finding shortest path between all pairs of vertices in a graph G with weight function such that weight function belongs to E implies R. R is the real number. Okay. That means that maps edges to real value weights. So that means we used to find all pairs of a graph and we used to find the shortest path between them. So let's say you have a graph like this. It should be a directed graph also. A, B, C, D, and there will be weights. So we want to find what is the shortest path between A to P, A to C, B to C, D to C, like that. All pairs you have to consider. That means AB, AC, AD, DC, and AC also. So all pairs you have to calculate what is the shortest path, what is the shortest path, what is the shortest path. This is called all pair shortest path. So basic difference between single source shortest path and all pair shortest path is that in single source we start from here and we reach some destination, we try to find the shortest path. But in case of all pairs means you have to make a matrix that will give the real value, some value it will say. So that means at the end you will be having some matrix which will be like vertices will be there and every entries will be the distance, shortest path. This and all pairs will be, so A to B you will be having a shortest path, B to C you will be having a shortest path, C to D you will be having a shortest path. All this thing has to be displayed at the end of the algorithm executed. So this is the basic difference. Many doesn't understand what is all pair shortest path, what is single source shortest path. So all pairs you have to, as many number of pairs are possible, you have to calculate all pairs. This is called all pair shortest path. So there may be more than one algorithm for all pair shortest path, not only Floyd-Warshall. I am not aware of that. In case of Floyd-Warshall, what is the catch? The catch is interesting in case of Floyd-Warshall. It's an interesting algorithm. We already know little bit about the strategy that Floyd-Warshall uses, which is nothing but the catch is in case of Floyd-Warshall is we will use dynamic programming framework. All of you remember dynamic programming? Dynamic programming framework. In case of Floyd-Warshall, that is the first thing. Okay. And another interesting thing is that for the time being, negative weights could be, so negative weights could be present but we assume that there are no negative weight cycle. Okay, this is another assumption, then no negative weight cycle is there. Okay, then it will be difficult. Okay, now what is the basic difference between Floyd-Warshal and other algorithm is that the structure of the shortest path. Okay, how to formulate the structure of the shortest path? The structure of the shortest path, that is the intention. All pair shortest path you have to calculate. Okay, so what you have to do, we will consider the intermediate vertices of a shortest path wherein intermediate vertex of a simple path other than, so here shortest path P, which is P is nothing but V1, V2 up to VL. This is shortest path P, where an intermediate vertex of P other than V1 or VL, that means starting vertex and ending vertex. Apart from that, any other intermediate vertex you can pick, that is any vertex in the set V2 to VL minus 1, because you have picked one intermediate vertex, let's say VK, which should be there in between V2 to VL minus 1. Okay, so that is how we have to choose the intermediate vertex. So this is the vertices, intermediate vertices, which is a set made out of k vertices. That is actually forming the shortest path, and P be the minimum weight path from among them. Okay, the Floyd-Warshal algorithm exploits the relationship between the path P and shortest paths from I to J with all intermediate vertices from 1 to k minus 1, because if you pick, the relationship depends on whether or not k is intermediate vertices on the path P is that k is the intermediate vertices of path P, then all intermediate vertices of path P are in the set from this. Okay, meaning is that we have to choose a path, we have to choose a vertex k from, let's say 1 to up to k. These are your vertices that is participating in the forming the shortest path between I to J, and k is the intermediate vertices. Then it will look like this. Okay, so path P, shortest path from I to J, and k is the highest number of vertices. That means let's say 1, 2, 3, 10 is the kth vertex, then 1 to 9 are the other intermediate vertices which is forming the shortest path. Okay, so now how should we process for this algorithm? We have to formulate a recursive. What is your question? Tell me, first bench. What is the question? You said start something. Which one? Structure of the shortest path. The structure of the shortest path is the heading. How to formulate the structure of the shortest path. Consider the intermediate vertices. We will consider the intermediate vertices 1 to k. This k number of vertices between I to j, that let's say I am considering I to j, two pair of vertices A and B. In between many vertices will be there. Which is the shortest set? That set will be 1 to k. Just I am telling the mathematical formulation, nothing else. Okay, 1 to k number of vertices will be there in between, that will form the shortest path between A to B. So this is I, let's say this is J, in between I have k number of vertices. What they are saying, k can be the last vertex. If it is the case last vertex, then k number of vertices will be the remaining vertices. So you have a set of vertices which is nothing but intermediate vertices, that is formulating the shortest path between any two vertex I and j. That's all. This is the discussion. Okay. Now how to do that? So based on the above observation, we define the recursive formula. Now recursive formula, when it will come, as I said, it will be little bit about the formulation is bit similar about dynamic programming. So dynamic programming, every time you update and get the final thing using table. Similar type of stuff will happen here. We will be having a tabular format or matrix. Okay. So dij be the weight. Dij be the weight of a shortest path from I to j, for which all intermediate vertices in the set 1 to k, where k equal to 0, a path from I to j with no if k is 0, that means no intermediate vertex, only one vertex is participating. If value of k is more than 1, that means at least two vertices participating. Okay. So if it is k equal to 0, then directly the weight, that means let's say this is 2 vertex and weight is 2. There is nothing intermediate vertex. So whatever is the weight, let's say 2 is the weight, which is nothing but wij. So that wij directly will become, any recursive algorithm will be having a termination point. So this is the termination. Otherwise, what you have to do? For that, I will show you one simple thing. Then I will come to this mathematical formulation where you will get interest. Okay. Let's say I have a graph like this. Okay. So you have to exclude the self loop. If there is any self loop, you have to exclude that. Self loops are not allowed here. Okay. Self loop you have to exclude. So basically what is happening here, just we are writing di comma j. Let's say we are trying to find the path between d vertex 0 and vertex 1. This is I, this is j. Okay. So vertex 0 and vertex I, cost is nothing but 9. Cost is nothing but 9. Okay. So if we have calculated direct costs, this is the direct, whether any other path which including the intermediate vertices, let's say k number of vertices, and that can be vertex or vertices. So if you include 2, this is the intermediate vertex. Let's say only one vertex you are allowing between 0 to 1 path calculation. You are thinking, okay, I will go through other path which will include only one vertex. In that case, the cost between d0 to 1, the direct 9, d0 1, if you allow vertex 2 to be participating vertex here, this 2 vertex, so then the cost will be 0 1, distance of 0 2 plus distance of 0 to 1, which is nothing but 2 plus 3 5, which is minimum. So basically what we are doing, like if you are writing here minimum distance of direct path between 0 1 comma and distance of 0 2 plus distance of 2 1. So this is 9 and this is 2 plus 3, which is nothing but 5. So minimum is 5. So you will choose this path if you allow only one vertex to be calculated, one vertex to be participating vertex. Okay. So this is there. So similarly, if you allowed vertex 2 is this. Okay. So for k, what will be the situation? For k, let's say if you generalize it, so then dij minimum of, what will happen? D I comma j, this is the direct distance, comma d I comma k plus d k comma j, whichever is the minimum will be the distance between I comma j. This is how Floyd-Warshall algorithm works. That means here I have included one vertex. Let's say if you include this one 3, in that case what will happen? If you include 3, that means the distance between 0 to 1 would be further decomposed into 0 to 3 and then 3 to 1. Let's say this is 1 or minus 1, whatever it is. So like that you can have. So in that case, how many vertices will be participating vertex? 2. Very good. So you understood this. Just I am telling you the basic thing. Okay, now let us go. And then now based on this is the algorithm for Floyd-Warshall. Okay, this is the algorithm. Main thing is this part only. This is the main part just now I showed you. So here the Floyd-Warshal algorithm, let us discuss the time complexity, because we have normally, if you have a matrix, normally it needs 3 loops. So obviously it will give a number of vertices is there, n cube is the time complexity, okay? Because normally calculating matrices you need 3 loops, I, J, K. For 3 cross 3 I am saying, 4 cross 4, what is that? You need 3 loops will be enough, I guess, right? Whatever it is, but it needs n square, okay? So n square is the time complexity for theta, n square is the time complexity for Floyd-Warshal algorithm. Now I will go to the algorithm itself. So this is the, okay, this is there. So now this is the algorithm, this is the graph. What I have to do, we have to calculate 2 things. One is the cost matrix, another one is the predecessor matrix, okay? So if you see here, 2 things you have to calculate. One is the D0. D0 is the initial matrix, which I will show you. Another one also you have to calculate, which is nothing but pi matrix. So pi matrix is what, just I will write it down, pi matrix. Pi matrix is the predecessor matrix. So basically what is happening, D matrix is already there. So pi matrix you can write it like this. For the simplification purpose, pi is, D matrix is the distance. D0 will be your first matrix, which is distance matrix that you have to calculate. Along with that, you should also calculate pi matrix, pi 0, which is called predecessor matrix, okay? So predecessor matrix can be defined like this, pi I comma j, okay? Predecessor matrix I comma j, which will be equal to, if it is nil, if I equal to j, after calculating D matrix only you should go to pi matrix. First you have to calculate D matrix, which is distance matrix. How to calculate distance matrix? Let us see. Then we will go to pi matrix. So distance matrix means what? If you have direct connections between one pair of vertices, you put it directly. So let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 vertices are there. So 1, 2, 1, 0. All diagonal element will be 0, 0, 0 like this. 1 to 2 direct distance is 3. You write 3. Wherever there is a direct distance, you put the value. 1 to 2. 1 to 3 is the direct connections. Yes, 8. Yeah, 8. We put 8 here. 1 to 4, there is no direct connection, so we will consider it is infinity, okay? 1 to 5, direct connection is there, -4. See here, Floyd-Warshal algorithm also considered the negative weights. No harm taking negative weight, but negative cycle should not be there, okay? Now 2 to 1, what about 2 to 1? There is no direct connections, it is indirect connection. 2 to 1 also will be infinity. 2 to 3, no connection is direct connection, direct direction is not there, so it will be infinity. 2 to 4, direct connection is there, 1. 2 to 5, 7. Then you have 3 to 1. 3 to 1, direct connection is not there, so infinity. So fill these, students. 3 to 2, 4. 3 to 3, 0. 3 to, no, 3 to 2, infinity, because no connection. 3 to 4. 3 to 4 also infinity, because this way connection is this way, not this way. So, and then 3 to 5, no connection, so the infinity. What about the fourth one? 2, 1, -5, 0, and then infinity. And then lastly 5, there is no connection because all are incoming, only 5 to 4 is there. So it is infinity, infinity, and then this is, I think, 6, and this one is 0. Correct? Distance matrix just I calculated, which is D0, first iteration, D0, okay. Now we have also to calculate this pi matrix, which is called predecessor matrix. Predecessor matrix, which is what? Pi should be such that if I equal to j, seeing the D0 matrix, you have to calculate the pi matrix, okay. Because one matrix at the end, when this loop will be, I mean, when this algorithm will be exhausted, one matrix, that is distance matrix, will tell you the distance, and pi matrix will tell you which way you should move. Understand, which vertices you should follow, so that you can reach to the minimum cost. So D matrix will give you minimum cost, but which vertices, because I have k number of vertices here, yes or no, students? Every pair of vertices I have k number of intermediate vertices. So which vertices, via which vertices you should go, that can be available only from pi matrix. So both the matrix you have to calculate. One matrix if you calculate, it will be half-hearted things. Okay, so pi matrix, what is pi matrix says? If I equal to j, that means I equal to j, then it will be nil, or if the weight between these two vertices is infinity, then also it will be nil. Nil means just you have to write nil, 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 okay? That means not applicable. Otherwise, if I is not equal to j, okay, let's say I is not equal to j, and weight also is less than infinity, that means not infinity, some value, then I'll put I only. Then it is only I means what? Row numbers. Okay, so here this matrix will be there for you, which is pi matrix 1, 2, 3, 4, 5. Okay, so you calculated D0, you calculate pi 0. So here 1 to 1, it is 0. If it is 0 or infinity, you have to put nil here. 1 to 2, some value is there, 3, which is less than infinity. Put the row value, which is I. If I is not equal to g, 1 is not equal to 2, and weight also less than infinity, which therefore you put the row number. Row number is 1. Like that, fill it, all of you. Then this is also 1. This also nil. 1 to 4, this is 1. 1 to 4, infinity, put here nil. 1 to 5, whatever 1 to 5 minus 4, which is less than infinity, so put 1 here. Complete the matrix pi 0. Let me see how many of you completed. Once you complete this matrix, which is pi 0, you will get this one. First iteration D0, pi 0 will get like this. Okay, pi 0 D0 will get like this. Now using this D0 matrix, you have to calculate D1. Okay, you have to calculate D1 matrix. So while calculating D1 matrix, you should be a little bit careful. Okay. So now we have to check that via wala thing, like K, what is a via K matrix I want to visit via K matrix. So basically I have this graph, this is my graph, and this is my D0, and this is, we are going to calculate the D1. Okay, so D1 means 1 to 1 you calculate it, which is nothing but 0. Okay, now 1 to 2 you want to visit this, like you can consider this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 1 to 2 you want to visit, which is like this one, 1 to 2. So here you want to visit 1 to 2. Okay, so 1 to 2 direct connection is there, which is 3, nothing, because from 1 you can, so for vertex 1 you can directly write whatever is available, because there is no via vertex, because 1 is the vertex and you are starting from 1. So 1, okay, whatever 1 to 3, 1 to 3 direct connection is there, right? 1 to 3 direct connection 8, no problem. So 1 you just have these all vertices, all weights, no problem. Now 2 to 1 though we can't visit, because infinity normally cannot be avoided, because when the infinity is there, no, it will be very difficult to replace the infinity weight, because infinity is usual. So okay, anyway, so let us see. So 2 to 0, 2 to 3 I want to visit, 2 to 3. So according to the definition of Dij, what do you have to do? We have to first find Di, j, Dik plus Dkj. This is the scenario, and minimum function is there outside. So Di, j means first I have to calculate 2 to 3. Main actual distance is how much? 2 to 3. Actual distance is infinity. So you put here infinity, minimum, and then 2 to k. I am now allowing this is D1, I am allowing k equal to 1. Vertex 1, via 1 I am allowing, okay, so via vertex 1. Only one vertex I am allowing, which is vertex 1. So if you allow one vertex, then it will be like what? It will be like 2 to 1, this dik I am saying, okay, 2 to 1 plus 1 to 3, 2 to 1, 1 to 3. Now what is the minimum of infinity? 2 to 1 already we calculated infinity plus 1 to 3, 1 to 3, whichever 8. So infinity plus infinity, again it is infinity, this is also infinity, minimum is infinity. So you put it here infinity like that. Finish it up, students. So this is done. And what about this one? This will remain 1. Check it out, because 2 to 4 you want to visit. 2 to 4. So 2 to 4 means minimum of 2 to 4. First it is 2 to 4 direct connections, and then 2 to 1 plus 1 to 4. So 2 to 4, what is the earlier calculated distance? 2 to 4 is 1 only. So minimum of 1 comma 2 to 1. This is also 2 to 4 is already 1. 2 to 1 is infinity plus 1 to 4 again infinity. Minimum is 1. So already 1 is there, so it won't be replaced. 1 will be there only. Okay. Now here like that 7. So if you finish this now, it will get like this. Next matrix. Okay. So simultaneously you have to calculate the pi 1 also. Calculate pi 1, students. Pi matrix. So pi matrix means what? It will be nil. This will be row number. This will be no row number. This also will be nil. This also will be row number 1, and this will be infinity nil. This is row number. This is 0 also will be nil. Infinity will be also nil. This will be row number 2. Here it will be 2, right? This also row number 2. Finish it up. Once you calculate, so you will be having 3 as like this. Nil. This is 3, right? Now here it is 4. No, one second. So what about 4 to 2? 4 to 2 is? No, 4 to this one, 4th. No, 4 to is 5. Earlier it is how much? Earlier it's 5 only, right? This is. One second. This one I am taking. This is D0. I have infinity here. Here I have changed. Here I have changed 2. You are saying that 4. Because it is infinity, earlier this up to row 1, 2, 3, nothing, no changes happen basically, right? But here when you enter to the row number 4, earlier pi matrix, you see this is 4. This is nil. But here you are saying it will be 4, right? So once this type of scenario happens, nil to 4, you don't directly write 4, you write 1, because first time it is happening, so you have to write 1 here. That you should be careful little bit. Next time it is 5. Here also same thing will happen. Earlier, here it is infinity, and here it is nil. But I think next iteration you will get how much? 4. So you don't write 4, write here 1. 1, 2, 3, 4 like that you will increase. Okay. So this is little bit you have to be careful here. Okay. So then remaining things will be as it is. So if you complete this, this is your final stuff. I mean D1 matrix and pi 1 matrix. Like that, if you continue this, finally you will get D3, D2, D3, and then D4, D5. Okay, this is your final things, D5 and pi 5. Why D5, pi 5? Because 5 vertices are there, so I have to go up to 5. Okay, so like that you stop here. Now what it says, so this D matrix, that means D5 matrix, D5 matrix says that from 1 to 2, let's say from 1 to 2, distance is, minimum distance is 1. This is the final outcome. This is minimum distance. 1 to 2 minimum distance is 1. You should go by a vertex 3. Now if you see this, the graph, 1 to 2, minimum distance is 1 to 2. That means this distance, minimum distance is 1. You should go via 3. Now if you go via 3 means it will be like this. See this path, 1, 5, 6, 4. That means this is minus 4, this is 6, 4 to 3, which is minus 5, and then 3 to 2, which is 4. So total cost is how much? 10 minus 9, which is 1. That's all.